So a couple of inspirations here at the conference. First was that I decided to wear this because Redbeard wore something nice yesterday, and then he ditched me. And the other was that the Viacom presentation yesterday was both interesting but also entertaining, and I was inspired to make some updates to my presentation last night to try to bring a more entertaining vibe. So we'll see how we do here. Also, I think I'm planning to maybe be a little controversial in this talk. So if I have not irritated at least a few people to come down and argue with me afterwards, I'll consider this a failure. All right, so Samsung has 490,000 employees. So this is what comes along with it. Probably ratio of disclaimer to number of employees isn't bad. So there. Okay, so here's a future that sucks. Here's the future that we do not want. Here's a future that will make you sad. This is a present that many of us have or are headed towards. Let's deploy this horrible mishmash. I guess I could say dog's breakfast, but that really wouldn't be in keeping with my theme. Let's deploy a whole bunch of stuff all different ways and then try to figure out how to actually operate it in a reasonable way. Enjoy sub 10% utilization as all these different systems are used to run their own thing, have lots of reliability and performance issues. Ugh, even sadder. Okay, so a lot of talk about Giphy. This is an attempt to put a little bit more refined view as to what that really means, how we think about it in terms of utilization, efficiency, not just of the machines, but efficiency of the people, being able to deploy very fast, high quality, low licensing spend, lots of automation, to have lots of analytics. So this is, instead of Giphy, I've been calling this industrial grade compute. You could certainly argue a lot of what we do in big IT today is more like craftsman's grade, lots of carefully handcrafted stuff. So that's what we want. That's the kind of kitties we want. Yeah, so this is what we want. Woohoo! All right, so let's talk about open source for a minute and why this is so important. This is really fundamental. It's all about risk reduction and control. If we're using open source, we have our own engineers. Lock-in is not a problem. We have maximum control. So this is where we're headed. I'm going to talk a lot about open source in the course of this presentation, and I thought it was good to just say an extra word about why that's so important. After the Viacom presentation, I was scratching my head, like, well, where can I get a bunch of imagery that I'm not going to get sued over by large media company lawyers? And someone mentioned to me that you could find cat pictures on the internet, so. I think it was at the party last night someone told me that. I thought that was pretty cool. Okay, so here's one of our goals for doing all this. We need to be able to run in a bunch of different places. So I'm really trying. I was told that if I used too many buzzwords, I'd have to put quarters in the buzzword jar. So I'm not going to say hybrid. I'm not going to say hyperconverged. Hybrid, hyperconverged. But really, this is what we're trying to do. We want to be able to run with minimum change possible in a bunch of different places, our own data centers, wherever is the best place to run, including Amazon. We're spending a lot of time, as you could have guessed from the logos at the beginning, on Kubernetes. We think one of the great things about Kubernetes is there's a really great public cloud hosted option. So if we want to run Kubernetes in our own data center, we don't necessarily have to run our own Kubernetes stuff on GCE. We can use a public cloud version of it. So open source containerization is really our key strategy here. So, we get a bunch of benefits out of that. Freedom, portability. I mean, there's a lot of great things about containers. I think I'm probably preaching to the choir for a lot of you here. But really, this is these are all the kinds of reasons that this is a good idea for us. And then, the strategic elements here in the longer run are, this is the big thing. The dedicated cluster is dead. Building all these different systems different ways leads to all this trouble and sad kitties. So what we need to do is we need to be building large shared clusters. We need a common, consistent way of doing things across all of our data centers and all of our public cloud utilization. And the only way we're going to get there is to have one kind of turtle at the bottom. So you kind of have two choices in terms of turtle types. You can either take a page from the Amazon book or take a page from the Google book. In any case, either way you go, you're looking at needing to have great standardization, commoditization, automation. You got to do one thing well, and it's got to be as simple and easy as possible. And then, of course, and I'll talk a little bit more about this later on, you still have to support legacy applications, right? We're not going to build out this next-gen data center world and say, oh, by the way, only the new applications get to use it. That's a bit silly. And we're going to maintain control of what we're doing, and the way we're maintaining control of this is by using open source and contributing to open source, both. Okay, execution. So I'm going to talk a little bit. That was the engineer philosopher, if you will. I'm going to talk a little bit more about some specific stuff. So this is how we view our next-gen stack. Different clouds and options at the bottom. Container manager, which could be Docker, could be Rocket, could be something else down the road in the future. You need container-optimized networking on top of that. We came to believe that the reason that's a different color here on the slide, we came to believe that the container orchestration piece was really the keystone technology that we needed to focus on here and build up everything around that. And then we want to be able to run everything we need to run on top of that in a consistent way. You need to be able to run services like databases. You need to be able to run applications directly on that infrastructure. You need to have good PaaS options. But all of that has to run on a single set of turtles, managed well. That's a kitty stack, in case you didn't get the joke. All right. So container optimized, this is really what we mean by it. The right host, the right networking. I'm really happy to hear that there's been a little bit more talk about IPv6. IPv6 is going to be important to making this smooth in the future. Container optimized orchestration, again, is really what we believe is the keystone technology here. And being able to run high density per server is the orchestration, all of the technology has to be capable of doing that. Containerized kitty, get it? All right, so here's the point where I hope to ruffle a few feathers. Opinionated would get me a donation to the buzzword jar, so I'm using it ironically. Okay, so here's a choice. Why are we using Kubernetes? I wanted to talk a little bit more specifically about this. So here's one choice. Run Kubernetes on OpenStack. For us, wrong turtles at the bottom. You could run, well, here's an interesting one. You could run Kubernetes on Swarm. Yeah. This is a little bit goofy. You could do it, but yeah, anyway. Okay, so much more sensible. Run Swarm on Kubernetes. In fact, Swarm is one of the frameworks that we think we need to support on top of our turtles at the bottom. Kubernetes has got much more sophisticated operations, control, scheduling, but Swarm is a convenient tool. A lot of people use it. So this is a pattern that makes a lot of sense. Okay, so here's something that you see talked about a fair bit. Certainly this is a possibility. Let's run Kubernetes on top of Mesos on top of OpenStack. Okay, first of all, Kubernetes is not a PaaS. Perhaps we can get some Q&A about that later on if you want. It's a containerized infrastructure piece, so it does a lot of the same things that Mesos does. But this does kind of lead to something that we started talking about a lot with Kubernetes, which is there's sort of like type 1 and type 2 users. I didn't want to use type A and type B, since I think that would be too overloaded after the cloud discussions yesterday. So there are people that are interested in using Kubernetes to kind of manage a single application. I've actually had people, so I'm very involved in the Kubernetes scaling group. I've actually had people come up to me and say, why would you want to run Kubernetes on more than a couple dozen servers? That seems kind of silly. Like, well, okay, you're clearly anyone who comes up and makes that comment to me is clearly a type 1 user. We're a type 2 user. We want to be able to use it to manage data centers at scale. Okay, so deep stacks are complicated. So I think this would be a better way to think about it. Great, you're an OpenStack shop. You want to use OpenStack shop? Fine, run Kubernetes on OpenStack if that's what you want to do. Run Mesos on OpenStack. This is a better deployment pattern. I think this would be better still. So I and Richard Kaufman, who's also here from Samsung, we are veterans of the OpenStack wars. And I meant to mention one of the things Brandon said on stage. I was kind of trying to listen from the green room, talking about how Kubernetes is hard to install. I think anyone who says that has not tried to install OpenStack. When I did my first OpenStack project, I had 200 engineers, and we had difficulty getting it working well. Our first crack at Kubernetes, we got running with like 2 or 3. So the ease of use different. There's a long way to go. It's super important for Kubernetes to be accessible to new users, but the comparison there, I think, is apt. Okay, so here's where we're headed, probably kind of obviously at this point. Kubernetes, containerized data center, Kubernetes at the bottom, and then we want to be able to support all these other things because, of course, especially at a large company, we're going to have OpenStack users. We need to support them. There's going to be Mesos users running Spark. We need to support them. There's going to be dev teams trying to use Swarm. There's going to be paths. I'm going to talk more about paths here in a minute. Okay, so you run OpenStack. Now, when I say run OpenStack in Kubernetes, I don't mean run the control plane of OpenStack on Kubernetes. I mean run it all on Kubernetes. So I think probably, well, some of you are certainly aware that if you run a virtual machine at Google and GCE, that is actually running in a Borg container. So we're talking about, again, taking a page from the Google book here. So we would plan to run the VMs in the containers too. So a strategic conclusion here really is, if you're going to get the advantages of Giphy, there can be only one. That's a Highlander reference, in case you missed it. See, I can't get sued for a Highlander reference if it's this obscure. Anyway, if you really want the advantages of this, you have to have one at the bottom. Okay, so let's talk a little bit more specifically, like why did we choose Kubernetes? OpenStack. Lots of kind of well-known issues here, but sort of the big ones, and I think this is a danger for Kubernetes and parts of the ecosystem. Featureitis. The important thing here is simplicity, quality, stability, not lots of cool features, and I'm going to continue to bang the drum on that for as long as we're involved in these kinds of projects. Some lack of strong technical leadership. Hats off to the Google folks for doing a phenomenally great job on the Kubernetes project in this regard. It has known issues at scale, too much to get into here. I think really important, way too much religious fervor within the developer community on OpenStack. Nobody expects the Pythonistas. And this is a serious problem, and I think although Kubernetes is very much a Go-oriented project, I strongly feel that if there were as non-Go implementations of things, and there are things in there, if that's the best thing, I think the community will accept it and go forward. I don't get any sense of that kind of fervor on Kubernetes. So I'll say, I have used this in production. This is a qualified opinion. I'm going to make some unqualified opinions as well, because I'm on stage and I get to do that. Okay, so option Mesos. So we took a look at Mesos as one of the possibilities here, and I think Gabriel at Deis has said this better than I have. So I'm going to start cribbing the way he talks about it. But this was essentially, we came to the same conclusion for a bunch of the same reasons. Some complexity, although I would say it's better than OpenStack. But that does have a good ecosystem around certain kinds of applications, primarily in the big data world. But its roots are in scientific computing. It's a scheduling system, was not really designed as a sort of next-gen containerized application development environment. It's also kind of a one-horse game, which is Mesosphere. And we really felt pretty strongly, especially after experience with OpenStack, that we wanted to be involved in a project where we could make a difference, that there was a wide variety of different contributors from different backgrounds, and the Kubernetes project does that. Okay, so here's my caveat. I've not used Mesos in production, but we took a hard look at it and made a choice actually pretty early on Kubernetes. And this was kind of our rationale for it. And I think we felt pretty good about that choice, even though we chose fairly early. Okay, so I have to put this one up. It's not really an option. But people come up and talk to me about it all the time. Clearly, it's used in the small by a bunch of folks, but it's not really suitable for large scale. It has the same sort of single vendor dominated issue with it. I wouldn't even consider using this as a production container management system. This opinion is not likely to change for a while, so we'll see how the Docker folks do with this over time. But it's really like a one-shot. Right today, it's been more of like a one-shot deployment tool, not like a end-to-end lifecycle management system the way Mesos or Kubernetes are. Also, to the lock-in thing, clearly Swarm plus Rocket is going to be a weird combo, and we don't want to be tied into want to be locked into Docker. So our choice, Kubernetes, great community, built from scratch the right way by people who know what they're doing, a great community. At the time, it was pretty clear that we were making a choice for the future, that point in time, perhaps Mesos had some things about it that were better, especially if you looked at some of the larger scale systems, but we felt it was really important that we make a bet for a year from then, 2 years from then. And that's why we went in this direction. Again, we've been very happy with that. Multi-vendor support is really pretty important. Again, if you don't want to be locked in, you can't be locked into a single source of help. This is still nascent in Kubernetes. I think we're looking forward to a richer ecosystem here. Great contributors, really. Google folks, the Red Hat folks, CoreOS, it's just been a joy to work with all these folks. And you can run multiple container specs. We're doing a bunch of work now in the context of our scalability work with Rocket and Docker. So it's clearly coming along. Okay, so some concerns. I'm on stage, so I have a moment to soapbox just on a couple of things. Around Kubernetes, CNCF is the right direction. We were so excited to see things headed that way. It needs to go faster. We really need CNCF up and going. Featureitis risk is ever present. One dipstick check for this is what stuff gets discussed at the weekly contributor meeting. It tends to be demos of new cool stuff, which I know and I understand that's the sexy bits, but scaling and HA and reliability and operations tooling, analytics, all that stuff is really pretty critical. So again, we're going to continue to work on that and going to continue to try to push the community to let's slow down on features and make sure that the system's really right. Accessibility for new users is certainly critical, but I would say for us that's a number 2 issue. You definitely want more users. The more people in the ecosystem, the better. But again, it's actually not that bad. For more technical, if you're less technical, of course, you're going to need some more help. But for fairly technical folks, it's fairly straightforward. Okay, so a few words about PaaS. I was talking about PaaS earlier. So we need to support multiple PaaS frameworks. We have lots and lots of developers who want to use different things different ways. We do not want to dedicate clusters at the PaaS level. Refer to previous comments. Really what I'm saying here is that the vertically integrated monolith that is Cloud Foundry is a serious problem. We have been vocal and talked to all sorts of folks in the Cloud Foundry ecosystem about decoupling all of these pieces. I'll make another comment about Deis here in a moment, but I'll say on that topic, the Deis folks, I think, really get this in terms of needing to be able to kind of decouple these pieces and run the PaaS system on top of containerized management systems. So fundamentally, a PaaS should not be in the container scheduling business. It should be in the make lives good for developers business. Any of you who have followed the troubles that Cloud Foundry has with Diego will understand what I'm talking about. If you look at the horror that is the Bosch tooling, you will doubly understand. So we really want to push all of the paths folks who are working on this stuff to focus on value up the stack and run on systems that know how to do this kind of stuff best. So really kudos to Deus. Apache Stratus and OpenShift have both rebased onto Kubernetes. Hats off to them as well. You can see a trend here, which I think is the future. Okay, so I'm probably starting to run a little bit short here on time. Wanted to put a couple of details up here. We've been doing very specific work, especially in the scaling area. This has been kind of like our baseline stack. Some of you may have seen our like 1,000 nodes running YouTube videos and so forth. But we're really trying to do very careful, diligent work on understanding what does it mean to run at this scale and above. Really, the 1,000 nodes is a little bit arbitrary, but even when I asked the gentleman from Viacom, actually, like, well, what's kind of the knee-jerk on, like, what's a big cluster? 1,000 nodes seems to come up over and over again. We definitely need to get bigger than that, but this is our stack. We're doing a lot of work on AWS. We're also doing work on bare metal. We use CoreOS in all of those environments. We're using CoreOS, Docker, Flannel. We tend to be on trunk because we're looking at performance issues, which are tending to get worked on pretty actively. And then we can run applications on top of that. We have taken a little bit of a turn from the community in terms of the setup bits. We're using Ansible and Terraform, which is actually a pattern a bunch of other folks in the community are using. By the way, we've made all of the software available in our GitHub repo, which I'll publish here in a moment. It's another stack of kitties. Okay, so just what are we doing here? Well, we're not forking. We're staying involved. We're doing work off trunk. All the work we're doing, we're contributing back. Working very carefully in the, trying to be very positive players in the community. We've spent this year really working on kind of fundamentally how do you run 1,000 node plus clusters. Moving into next year, we're taking that work as our baseline and expanding more into networking and storage and some of the things that you need to do to support the legacy applications. You need more old school kinds of storage approaches. But the 1,000 node plus cluster is really our baseline for that work. Joe Beta, I think, is Joe here? There's Joe. So Joe and I are the co-organizers for what we call KScale. It's the Kubernetes scaling interest group. We meet weekly. It's been very active. Super great interactions there. Lots of positive progress. CoreOS folks have been involved. Red Hat's been involved. Other folks. So this has been really great. Google's spent a ton of effort on this. But I think there's an important point here, which is you don't get to buy Giphy. You don't get to buy industrial grade computing. You have to live it, and you have to understand it, and you have to understand it pretty deeply. And one of our ways to do that is to be involved in the Kubernetes project at a deep contributor level, and we learn by doing. So that's why when we're doing these things which are more sort of research oriented, we're doing it by building real systems and engaging with the community to see what it is they're interested in. So I'll make the offer. Anyone that has an interesting performance question, please come talk to me. We have reprioritized the work that we're doing on this large cluster testing based on input from the community. And I'm always interested to hear what you might be interested in on the performance side, especially. All right, so here's my contact info. I'm around, come say hi. I'll be actually at the CNCF, some of the CNCF meetings this afternoon, so I'll be around probably until lunch. Always happy to have a coffee if you're in Seattle. Please reach out if you're interested in the Kubernetes community, especially on the scaling interest group. And thank you very much. Do I have time for a question? A couple of questions? One or two? One question. One question. One question. Yes?
What would you pay for?
So that's a really excellent question. Did you have a reaction, Richard? So I think that there's plenty we will pay for, but what we will not do is we will not pay a vendor to get locked into them. That's the key. And there's actually plenty we're happy to pay for. I just can't get trapped by it. So, anyone? That was too quick. I got one more. Was there one here?
I was going to ask the same question, but you mentioned not talking about vendor lock-in and support and stuff. Like, when do you pay for support or other kinds of services?
we're happy to pay for support. We do pay for support. They'll laugh at me a little bit because we haven't actually used their support very much because, frankly, the product's been great, but we pay for support to CoreOS. So, all right. Thank you very much.